Okay, so we are going to look at a collision where we have to look at the x dimension and the y dimension separately, and then maybe bring them together at the end. So we'll pick one. We'll go with let's go with the x dimension first. So in the x dimension, let's see, the best way to write this. So we have the x component of our original momentum. Conservation of momentum says has to equal the x component of our final momentum total. But in the x, let's see, well, we have two possibilities. There are two objects in this problem. It could be the x component of puck A's momentum originally, plus the x component of puck B originally. And then after the collision, since it's elastic and there's still two objects, it could be the x component of A's final momentum plus the x component of B's final momentum. Now, if you read the problem carefully, you'll notice that the puck B at the start of the problem is just stationary. 0. In the beginning, you have A, which has its mass, times its x component of A's velocity originally. Now, you'll also note that there is no y component in terms of that, but all of its velocity is in the x. It's moving along the x-axis, so keep that in mind. Equals the mass of A times the x component of A's final velocity plus the mass of B, since it's moving after the collision, times its x component of its final velocity. Okay, so now I have some numbers I can play around with. Let's see. Let's go with 0.033 is A's mass. And they give me its starting velocity, which is all in the x, 4.34. Positive, going left to right. 0.033. Now, the x component of A's final velocity. A's final velocity is in this direction. It has an x component and a y component to it. If this is A's final velocity, then this is A's x component of A's final velocity, which would just be A's final velocity times the cosine of 65 degrees. Use the cosine to find the x component. And just to note, it would be positive, right? Going from left to right. The x component would still be that way, so we would put it in as a positive. So I'm going to write VA final, not an x component, just its final velocity times the cosine of 65 degrees. Plus B's mass, 0.066, times, same argument, B's final velocity, not its x component, times the cosine of 37 degrees. Now, it's a good time to make a note of this. That's cosine of 37 degrees. The reference angle there is down in this quadrant, which, just double check it. Whenever you look at it, double check it. The y component would be negative, but the x component is going to be positive this way. So it's okay. I'm good. I'm just going to leave that as a positive. So we'll fill in some numbers. 0.033 times 4.34. So I have 0.14322 equals, let's see, 0.033 times the cosine of a 65-degree angle. It's going to give me 0.0139 times VA final plus 0.066 times the cosine of a 37-degree angle. That's going to be 0.0527 times b's final velocity. But at this point, I'm stumped because I have two unknowns. So probably a good time now to go to the y dimension. Now, what do you notice in the y dimension? Well, if you look in the y dimension, in the beginning, A doesn't have any momentum that is up or down. All of its velocity is horizontal, so its beginning y momentum is 0. And of course, B's is 0 too because it's just stationary. So we start off with the same premise, that the original y momentum total has to equal the final y momentum. And I'll write this, although I think it's pretty obvious that we're going to get to 0, is that the y momentum for A initially plus the y momentum for B initially has to equal the y momentum for A finally plus the y momentum for B at the end. Well, like we said, there is this and this are 0. This one because it's stationary, this one because it's moving horizontally and not vertically at all, so there's no y component to its initial velocity, therefore 0 y component for its initial momentum. So I have a situation where 0 is equal to that plus that. Now, I have 0 equals 0.033 so I have A's mass, 0.033, times the, let's make sure I get this right, yeah, A's final velocity times the sine of 65. Plus, although I'm going to temporarily put the plus there. So, I'm not going to put a plus there because I know that the y component to B's final velocity is definitely downward. What I would really should do is use negative 37 as my reference angle. I'm going to use positive 37, but put in a negative. So I'm going to say the downward momentum here is going to be, let's see, 0.066 v velocity, final velocity of B, times the sine of 37 degrees. Which means the two of them have to have the same magnitude. If I bring that over, we'll simplify some things here too. Let's go 0.066 times the sine of 37 over there. Boom, it's going to be, and I bring that over here, it's going to be, well, no, let's not do too many steps. Let's see, minus 0.0397 VB final. And then I have 0.033 times the sine of 65. So that's going to be 0.0299 VA final. If I solve for one of these, so I have this equation, I can solve for one of them. And then I combine it with but also look at the other equation from the x dimension, Now I have two equations and two unknowns. There's a variety of ways you could solve this. I'm going to do it this way. I'm just going to take let's take the green equation here, this guy right here, the one up top, and work in green for clarity, and we're going to solve that for one of the two variables. So we'll bring the negative 0.0397 term over. So I have 0.0397 VB final equals 0.0299 VA final, and I'll divide both sides by the 0.0397. So I get that divided by 0.0397. Boom. So the final velocity for B is equal to 0.753 times A's final velocity. And then I'm going to plug that, since it's equal to VB final, in here for VB final, into the red equation. So I'll have 0.14322 equals 0.0139 VA final plus 0.0327 times 0.753 VA final. So I just plugged in, since VB final was equal to this, I plugged that in for VB final. And now I have only one variable. So I got to do some cleaning up. So we'll do this times this. And we'll get 0.0246 VA final. And over here we'll get 0139, there we go, VA final, equals 0.14322. Now we can combine these two like terms. So I'll have 0.0246 plus 0.0139 and get 0.03853 times VA final is equal to 0.14322. Divide both sides by 0.03853. Yep, that's just ugly. So 0.14322 divided by, that is going to be 3.717 or so meters per second VA final. It's positive, that's a good sign. Am I even remotely right? No. So where did I go wrong? Where did I go wrong? I found it. I paused it and I looked, but I found it. It's right here. Silly, silly me. Somehow my 5 became a 3. I can't explain how. There's no explanation for that sort of, well, bizarre, reckless behavior. So, this, my friends, is a 5, which would change things from that point on. Let's fix those things, shall we? Let's just pretend it never happened. So from here down, it's all goofy. There you go. Now, let's pick it up from there. So let's see if I get this right. 0.0527 times 0.753. That's going to get me 0.0396 VA final. Positive. 0.0139. I did the same thing before. VA final equals 0.14322. Combine like terms. So that plus 0.0139 0.5358 VA final. Divide both sides by the 0.05 number there. So I'm going to 0.14322 divided by 0.05358. I like this answer a little better, I think. 2.67 meters per second positive, which would indicate upward, which makes me feel better about the world, because A's y component to its final velocity should be upward. Actually, yeah, well, it's actually positive or negative doesn't make a difference, does it? Because we're looking at the actual velocity, which is at an angle. But 2.67 meters per second works for me. Now, for B's final velocity, we just got to plug her in. So we're going to take it, plug it back into, let's do this. Take a look at this right here, just inside the box. Don't worry about whatever I divided both sides by. So we're going to take that and use it. See if I can do that. No. There we go. And we'll plug this thing in for VA final here, and we'll solve this. So we're going to have, I probably could have picked a better one actually, but that's right. So we'll have 0.0397 VB final equals 0.0299 times 2.67. And we'll divide both sides by the 0.0397, so 0.0299 times 2.67 divided by 0.0397. Should do the trick. I get 2.01, and then we look up with some trepidation and concern and see, yes, look at that, 2.01. There we go.